Hello, my name is Tom Gavin, and I'm going to present a module on Introduction to Object-Oriented Programming. We'll use this as a starter module to learn more about Java and other things. Object-oriented programming languages follow these principles. They have a concept of classes and objects, encapsulation, polymorphism, inheritance, and object identity. And we'll take a look at these one at a time. First, we'll look at classes and objects. These are related to each other. You define a class first, and that defines, you're providing a definition of an object. The objects are the things that run when your program runs. They're created in memory, and they execute. An object is an instance of a class. You can instantiate as many objects as you want from a single class, but you need the class first. So when you write your program, you build classes, and then when you run your program, objects are created and they execute. So you think of a class as a cookie cutter or a blueprint. You create the cookie cutter once, the blueprint once, and you can create as many cookies as you want or as many buildings as you want from that blueprint. So a class is where we start, and a class is also known as a type. So we create a new type in our system. Each class can define 0 or more attributes and 0 or more methods that will be found in the objects. You think of attributes as the data part. Many attributes, most attributes are variables. However, you can define attributes that are read-only. The methods that you define provide the behavior. In other programming languages besides Java, they're known as functions or procedures. In object-oriented languages, we call them methods. An example class would be a class called person, and it might have attributes first name, last name, birth date, and eye color. So those would be the data attributes associated with the person class, and then the methods on person class might be run, walk, sleep, eat, jump. The convention we use is class names. We start with an uppercase letter, and if it's multiple words, we have upper camel case. And class names are usually nouns. Attribute names and method names, we use a lower camel case. So we start with a lowercase letter conventionally, and then we might have uppercase letters separating the words. Attribute names are usually nouns, and method names are usually verbs. Again, these are just conventions. You can create your own conventions, but these are the standards that most Java programmers use. A word about methods. Each method you define has a name. It can have one return value coming back from the method as an output. But it doesn't need this. So we call those void methods, methods that do not have any return value. And a method can have 0 or more input arguments going in. So when you define a class, you define the method signatures and the method implementation. So in the class, you define methods and attributes, but we're concentrating on methods here. It turns out that you do not have to implement the method. So a class can define a method with an empty body. That is, it could define a method with no code in it. It's just defining the signature, that is the method name and the input args. When we talk about attributes that are defined in the class, attributes have a name, they're data, and they have a type. So attributes, in Java, you can have primitive types like int and boolean, and you might have objects as well. It turns out string and date, these are object types. So there are different types of attributes, and we'll get into more details of that later. You can provide a default initial value for the piece of data you're defining, and most variables are dynamic. They can change at runtime. And they can take several states as the program executes. Java is a strongly typed language, so when you define an attribute, you have to say what type it is. You can't just leave it untyped as you can in other languages like JavaScript. Okay, let's take a look at the person class and see how these objects and classes relate to one another. So what I might have is a class called person. So let's draw that. We'll represent the class person as a box. And as we were saying before, we might have some attributes for this class. We might have a last name attribute. I'll just abbreviate it LN. We might have a first name attribute. And perhaps we have methods as well with this class. We might have a run method. And we might have a walk method. Now I'm not going to get too specific here. For example, I'm not going to specify the type of these attributes. Last name is probably a string, first name is probably a string, but I won't specify the type at this point. And run and walk, I put parentheses here to denote these are methods. I also put a line here to separate the attributes from the methods. But I didn't specify any input arguments or return values. So I basically just left the method name. And then what's going to happen, that's the class definition. And then at runtime, what's going to happen is from the person class, we're going to kick out an object. Objects we kind of draw as circles, but just for representation purposes. So here's a person object. And the person object that we create is going to have a last name. It's going to have a first name. And it's going to have a run method and a walk method. Now, if my program wants to kick out another object, I can. I can kick out as many objects as I want. Remember, the class is a blueprint. So I can kick out one person object. I can go and kick out another one. Now, the second person object is going to have the same attributes and the same methods as the first. And the initial values of the attributes would be the same, but as the program executes, we can change the attributes. So as the program executes, perhaps the last name is set to A on this object, and the last name may be set to B on this object. So the values of the attributes in the two objects may be different as we execute, but the actual objects are the same, of the same type. So they always have the same set of attributes, last name, first name, and the same set of methods, run and walk. Another principle of object-oriented programming is encapsulation. Encapsulation enables you to mark attributes and or methods to be private or public. If you have a private attribute, then only methods in that class of the same class can access the attribute. Likewise with private methods. If you have a private method, those private methods can only be called by methods in the same class. They could not be called by other objects that are outside that class. Generally, attributes are made private and methods are made public. So let's take an example with our person class that we were talking about earlier. Let's say the attributes last name and first name are private. I'll denote that by putting a minus sign in front of them. And let's say the methods are public. So now when we instantiate the object, we might draw it this way. We might draw it with two layers, and we'll put the private information on the inside. So we'll put the last name and first name attributes inside the object, not accessible to the outside world, if you will. And we'll put the methods, run and walk, in the public interface. So now if we have some other object in the system and it wants to access the walk method, that's fine. If it wants to access the run method, that's fine. But if we try to access inside the object, we're blocked. So this other object, I'll call it object 2 here, is not allowed to access the last name and first name attributes directly. They have to go after those attributes indirectly, and we'll see how to do that later. So this is an example of encapsulation. Polymorphism allows you to define method names, the same method name, in every class, and the system will keep track of them. The term polymorphism means many names, but the idea is that you can have totally unrelated classes with the same method name inside, and these methods will have different implementations, different code in each class. The system will automatically figure out which method to call based on the context, and you could also have the same attribute names, if you will. So two different classes, two unrelated classes, could have the same attribute name, and they're completely separate in the system. Here's an example of polymorphism. What I've drawn here is two classes. I have a class called bird and a class called airplane. And the bird class has a fly method and a tweet method. The airplane class has fly, takeoff, and land methods. Then what I've done is I instantiated a couple objects. I created one bird object, and the bird object has a fly as well as tweet, but I just want to concentrate on fly for now. And the airplane class also has a fly method. So when I instantiated two airplane objects, and I need to differentiate these objects in memory somehow. So I'd like to bring in the concept of an object reference. So in this case, B1 is a reference to the bird object. A1 is a reference to the first airplane object, and A2 is a reference to the second airplane object. And the references is how we keep track of the objects and how we talk to each one. So if I have some other code here, I'm not going to define the entire code here, just give you a little snippet. Let's say I have some other object in the system that instantiated these two objects at one point and then held these references. Then I could talk to the fly method. So I could say, for example, a1.fly. And what I'm doing, this is a line of Java that's calling the fly method on the object A1. A1 is referencing an airplane, so I'm talking to the airplane's fly method. If I say A2.fly, I'm also calling the same fly method because airplane class defines the fly method one time, but I'm calling that fly method on a different object. So even though the code is the same in these two fly methods, it's actually being called on a different object. So the system keeps track of that. And likewise, I can call b1.fly. Now when I call b1.fly, this is a completely different set of code here because it's the fly method on the bird class, not the fly method on the airplane class. So the system, even though we use the same name in all three cases, it keeps track, based on the object reference and the object you're talking to, which fly method you're actually going to call. And that's what polymorphism is all about. Let's talk about inheritance. Inheritance is another principle of OO languages. It turns out that classes can form a tree, called an inheritance tree. So we can have a parent class, a child class, a grandchild class. And we also can call this superclass, subclass. They have the same meaning. Inheritance does not apply to objects. You don't think of objects as inheriting from other objects. But since objects are related to classes, they're going to gain the benefits of the class inheritance. Here's an example of inheritance. We might be building some kind of drawing program, and it's got a it's going to allow the user to draw lines, rectangles, squares, ovals, and circles. So we might form an inheritance tree like this. We might have a class called shape, and then a subclass, 3 subclasses of shape called line, rectangle, and oval. And then square might be a subclass of rectangle, circle, a subclass of oval. So in this case, the inheritance tree is going from a general class, shape, to a more specific class as you go down the tree. That's a pretty common occurrence, a pretty common way of doing inheritance, but you don't have to go from general to specific. It doesn't have to follow that logic. Inheritance can be quite useful in that if you have a subclass, it inherits all the attributes and methods of the parent class for free. So you don't have to re-implement those methods or attributes in the child. They just come for free. That's good and bad news. The subclass inherits all the methods and all the attributes, even if some of those methods and or attributes are unnecessary. And the subclass is allowed to override methods from the inheritance tree if the parent classes allow it. It's always okay for subclass to add new methods and attributes as they see fit. Okay, so let's take a look at an example of inheritance. Let's say our system has 3 classes, shape, rectangle, and line. And shape has an attribute called line color and a draw method. Rectangle has an X and a Y position, 2 X and Y sets actually, to pick the corners of the rectangle, and a fill color. It also has a draw method. And line has the 2 endpoints of the line and a draw method. So, as shown in the previous example, what we're going to do is inherit. We're going to try to show inheritance. So both rectangle and line classes inherit from shape. So we have a superclass and 2 subclasses. Then at runtime, what we're going to do is we're going to generate objects. So we might create a shape object. Maybe we create a couple of rectangle objects. And maybe we instantiate 1 line object. So if I look at these 4 objects, they're a little different. The shape object has a draw method, and the implementation for draw, whatever shape defined here. And it also has an attribute called line color. I'm just going to put the count of attributes here instead of drawing them all in. So it has a line color attribute, but no other attributes. The rectangle object, these 2 rectangle objects, have a draw method as well. Different implementation than shape. But the rectangle objects have 1, 2, 3, 4, 5 attributes in a rectangle, plus the 1 attribute that was inherited from shape, the line color attribute. So each rectangle object actually has 6 attributes inside. The line object has a draw method, and it has 4 attributes in addition to the line color attribute inherited from its parent class. So the line object has 5 attributes. So we get some advantage of inheritance here in that the rectangle and line class do not have to define a line color. They get that attribute for free, even though they don't declare it inside the class itself. Since they're inheriting off of shape, they get that attribute without any extra coding involved in the 2 subclasses. Now you might ask, well, why did I design it this way, since both line and rectangle have these 4 integers, let's say, the 2 corners of the rectangle and the 2 endpoints of the line. We could have moved x1, y1, x2, and y2 up into shape, and then they would not have to be redefined down in rectangle in the line class. The downside there would be that if we had another class here, let's say called oval or triangle, let's say, well, the class oval, if we wanted to inherit from shape as well, the oval class probably wouldn't make use of those x1, y1, x2, and y2 attributes of shape if they were in here. Again, inheritance, this is the good news and bad news of inheritance. Anything that's defined in the parent class is inherited by the child class, even though it's not really necessary for that child class. So yes, we could have moved these 4 attributes up into shape, but then oval, it would have been awkward for the oval class to inherit those 4 attributes. So you have to take this into consideration when you define your inheritance tree. Another concept related to inheritance is the ability to create abstract classes. You can mark any class as being abstract. The opposite of that is known as a concrete class, and most of the classes in the system are concrete. Abstract classes cannot be instantiated, that is, you can't create objects of these classes, but they can be subclassed. So at first, when you think about an abstract class, you say, why would we need it? Why would you build a class that you can't create an object off of? Well, it turns out this is the way that you can provide baseline functionality and partially implement a finished system with abstract classes, say, and then you subclass those abstract classes to finish off the last piece of the implementation. It turns out you can also mark individual methods to be abstract, and when you do that, you define a method, you define its signature, but you don't define any implementation code. So you push the implementation for that method down into the child and or grandchild classes to implement that abstract method. Let's go back to our previous example and see how abstract classes and abstract methods might apply. So what we could do, shape is a pretty generic thing. We could make the shape class an abstract class. And we could also, in addition to that, make the draw method abstract. Those are 2 different operations. You can make the class abstract. If you have an abstract method, your class is automatically abstract. If you do that, then, and in this case it makes sense in that if you tried to write the code for draw, it'd be tough to come up with that code because you're drawing some arbitrary shape. You don't even know what shape it is. Is it a triangle? Is it a circle? And you have line color, but you don't really have enough information in shape to write the code for draw. So we make the method abstract, and we make the abstract class. Once we've done that, then this operation is illegal. We're not allowed to create any objects of class shape in our system. It's an abstract class. However, what we can do is create subclasses, and these classes are not abstract. These classes would be called concrete classes. And these classes can be instantiated, and they would implement the draw method. So the draw method in rectangle is not an abstract method. There's the code for draw is there, and the code for draw in the line class is also there. So it's okay to instantiate rectangle objects and line objects in our system, but no shape objects. This draw method in the subclass is also known as an override, because what we're doing is overriding a method in our parent class. So is the method in line. They're both override methods.